very much, George, and welcome to everyone. And those of you that are in South Africa for the first time, in particular Cape Town, welcome. It looks like you brought the good weather with you, so you must come more often. But thank you, and I hope you're enjoying your stay here. As George said, my name is Trevor, and I'm with a company called Optron. We've been supplying and supporting geospatial technologies into the sub-Saharan African market for roughly about 25 years now. And 22 of those years we've been a Trimble business partner. And any of you that know Trimble and their distribution strategy, we really are very closely aligned in terms of how we do business, and that's their route to market. So what I'd like to try and do myself and Brent this morning is just talk a little bit more about how do you use all of this technology and approaches that you very clever folks come up with and actually start making some money with them, and an approach in terms of growing the business, and why this specific topic of 3D indoor mapping and modeling is critical to one of the strategies that we have in terms of expanding our business, and what is our approach in terms of trying to apply that technology as a business approach, and not just as a sense of a technology that we can supply to our customers. So I'm going to be talking a little bit about that. It's going to be quite brief, and then Brent's going to be diving deeper into some of the technology that we actually use to do the mapping and the modeling. So very much, many technology solutions businesses have start off with a very horizontal approach to the marketplace. And what I mean by that is they come up with a good technology, a bit of firmware, software, and then they would supply that across various industries in the marketplace. You know, if we look at GPS technologies, which we are quite well known for the field component, pretty much we've come up with some hardware technology, some firmware, software on that, and we then supply that into, let's say, mining, construction, utilities, or government departments. But essentially what you're doing is you're taking a solution and you're supplying it across that. So you find a geospatial practitioner, a surveyor, for instance, in the mine or on a construction site, essentially is using the same technology in the field, with maybe the interface being slightly different in the format, and when he gets to the office, that the base is still the same. And one of the problems with that sort of horizontal approach to the marketplace is that you really have only a number of options in terms of growing your business. You can either find more industries to which your technology can be used, or you have to find more territories, or a combination of the two. And that's always a strategy that continues, but you know, at some stage that curve starts leveling off because there are only so many industries and territories that you can cover. And what a lot of companies do, and this is really what I wanted to talk to you about, is they start looking at the market more in a vertical sense. How can you look at any of those specific industries that you are addressing with your need and actually start selling deeper into that industry? How can you effectively supply more solutions to the customers in that industry? And the approach that we have to do that is to identify an industry that we obviously feel would be applicable for our solutions. And then really, and this is the key, to start understanding the workflow or the continuum of that industry. How do they operate? From the inception phase, if it's a project, to the completion and the handover and operation, or how does the workflow in that industry work? And so that's almost the first step. Understand how does that industry operate. If you talk about a highway that's being constructed, from the design phase through to the construction, the building, the earthworks, and then the maintenance and the handing over of that. So that's really the change that we're seeing in the industry, that there's much more vertical focus in terms of the solutions, understand the workflow, and then effectively understand what is our current entry point with technology into that industry, and then move upstream and downstream of that workflow process to offer solutions to make that workflow a lot more productive, automated, and that's where the real value comes in. So one of the first industries where this strategy was very successful for us and for Trimble was in the civil, and I'll bring it back to the 3D modeling in a second, but was the heavy civil market, where we supply technology into the heavy civil market, but effectively into the surveying component of that. So you'd have surveyors use the technology. Let's use an airport or a highway that's being constructed. They use the GPS and related technologies to set out the highway, to do the earthworks, etc., etc. And in terms of going deep into that industry, the first step was to understand, well, what's the process from the design of that highway through to the feasibility study, to the construction thereof, the monitoring, the maintenance, etc., after it was built, and then to expand just adjacently to that. And this is a very mature industry for us in terms of that approach. If you look at Trimble, it's a public company, so I can talk about the revenue that will be over about $2 billion this year. They probably do close to $600, $700, $800 million a year just into this industry with this strategy. And they've grown that by expanding the continuum beyond just that one entry point. So the obvious step in civil construction was to take the positioning technology and put it onto the machine. So you've got some smarts on the machine, but effectively what's happening is you're taking the design of that road, airport, etc., and digitally in 3 dimensions putting it onto the machine that allows that machine then to work according to that design. But the real value is that that machine is connected to the design in real time effectively the whole way. And as the machine and the tool is working, it's updating that design and model. And you have your designers and engineers and everybody on the office side that can receive that data and that model as it's actually being built out there. And there's obvious advantages to that. So you can see that the technology needs to start catering for not only the geospatial component, but also the real-time connectivity to the office, which then makes the business processes and the decisions in the office component a lot more efficient, especially if that connection is in real time. We talk about the connected site, and it's not so much connecting that site to the office, but it's actually going across the continuum. And you can actually go upstream with the data flow. If that design sits on the machine, well, where did that design data come from? Well, somewhere there was a piece of technology that was used to actually design that road or the airport. And at some stage that design was used, or that the data that was used in the design of that technology, of that airport, had to go through a feasibility study. And so you can actually follow the geospatial data all the way upstream to the inception phase or the design phase, and you can also do that downstream. And that's really the value proposition here. We're saying that that flow of that geospatial data needs to be as automated and efficient as possible to actually get the productivity gains that you see in the process of constructing a highway or an airport. And because this is a very mature market for us, there's a lot of data to support that up there. But you get easily in the order of about 30+% productivity enhancements in having this approach and having that automated data flow. And the other very important impact for our customers is the amount of rework that gets reduced. Definitely over 50%, where you get to site and the model was not what it was thought, and you actually have to do rework. If you look at some of these industries, the rework component can be over 10% of the value of the project. And then of course there's a large safety component as well in many of these industries which are critical. So that is an industry that we've been involved with and have had a lot of success in, as I've described. And to bring it back a little bit closer to this, the theme of this conference, another industry that we've selected and which we're going to be focusing heavily on is that initiative called Trimble Buildings. And what that really focuses on in terms of an industry is the vertical building construction market. Okay, we feel that that is an industry which can benefit tremendously from this approach of covering the whole continuum or workflow in terms of our approach. So, as I said, we've got, we try and understand the whole workflow of this industry, and we found out very quickly that although there is a dimension of 3D modeling occurring in that industry, it's a very, very discontinuous process at the moment. Remember, I mentioned that the value in introducing this technology is to make the workflow a lot more efficient. And if we look at the vertical building construction market, it's a very discontinuous process. You're talking about, time constraints, big budgets, and rework, for instance, is a massive result of that discontinuity because of the different professions and the trades that's involved in a project like that. So what you have here is just a slide to describe the approach we have when we go into a new industry and why it's so important to have 3D mapping and modeling technology. So what you have here is just a timeline of acquisitions that Trimble have made, but specifically to build the strategy of Trimble buildings alone. This is for no other industry, it's just the focus. It started, as you can see, a long time ago, and a company like Trimble have spent close on $1 billion in acquiring specific niche technologies and companies and services in that continuum. Why is that? The reason is to cover that whole continuum. It's not just to buy a company for revenue, but we want to stand back and say, if this is the whole workflow process of vertical building construction, well, you need to have a capital management software, a piece of technology that manages the spend on a project. You need technology that helps contractors bid for a project. Because once you have that and you tie it to the 3D model, it's a lot more efficient than if it's a standalone package that's operating out there. And so you can carry on with the architects, the general contractors, the structural guys, the MEP guys, etc. So one way is acquiring companies to try and cover the continuum from a technology point of view, to get a beachhead in that technology. And the other strategy, of course, is to have your R&D spend directed so that you plug those gaps. So effectively, and I've got another slide which I don't have right here, but once you've mapped out the workflow of an industry and you overlay all the technologies that you have, as well as all the stakeholders in there, it very quickly becomes apparent where those gaps are. And it's those gaps that you need to fill with R&D and acquisitions, and that's essentially the approach that I'm talking about here. And what you find happening is, if you've got that approach, as a company you start moving away from just supplying positions and sensors, like you see in front of us here, which is still a big part of our business. But long ago we've moved away from saying, in fact, that it has to be our sensors, and we're saying we can wrap around that, first of all, the connectivity, as I described earlier. It's very important to connect the office, or effectively the model, to the machine or the tool or the person out in the field. And the two update one another as the process or the project evolves, and there's massive benefit on that, but also the connectivity between the various workflows, hence the term a connected site. And as a result of that, modeling becomes a lot more critical. You have to be able to do modeling in real time if you're really going to be the benefit. Brent's going to talk a bit about this specific product we have, which generates a lot of data, and to make that data useful, there's got to be a modeling component, an efficient modeling component. And the nice thing about that approach is once you start getting to there, you can then really start looking at the analytics side of it, whether it's on a minor construction site or building one, a large building or vertical building that's being constructed. If you can start applying analytics methodology to your processes, that's where you start getting a lot of efficiency. So you can see that the skill set required from a company like ours now goes more towards actually being able to integrate the technology and the data that it produces into the business processes of an organization, because that's where the value lies. So you'll find that whatever's happening out there in the field is connected all the way through to, let's say, a mine, the financial director of a mine or financial officer making decisions on budget in terms of what's happening, because he's getting that data so quickly. So that just describes nicely in terms of how the business is evolving, but it's still pinned on this concept of positions and sensors out there that's collecting the data. And that's where I think, you know, people playing in our space is positioned strategically very powerful, because they understand the field component and migrating back into the office and into the business processes. And you're finding a lot of companies that play in the business on the office side is trying to migrate to the field component to make the process more efficient. So, now without going into too much detail, as I mentioned, I'm just trying to describe a process here in terms of the strategy and how it underpins what we're talking about here. But going back to this initiative of Trimble buildings, as I mentioned, you look at who are the various professions and trades that make up this continuum in a typical vertical building that's being constructed. And if I talk a little bit to the concept of 3D mapping and modeling for architects, for instance, it's an obvious one, right? The ability to map and model what's happening out there in the field in near real time is what makes a lot of architects very excited. You know, they come up with a beautiful design, a functional design, but just knowing that that design is actually being executed in the field is critical. And having that in near real-time information can save massive rework costs because the model can be adopted. As I mentioned, this is a real-time connectivity. We might not be quite there, but that's where things are going, so that if there's a big deviation from the as-built versus the design, the various professions can adapt to that very quickly. An interesting point here in the South African market is, I spoke about the entry point into a continuum of an industry, and very much in South Africa still, the architect plays that pivotal role, which is the interface between the owner or the developer and the professions, as it were, is that point of entry, which we're very grateful for, because you know, architects have adopted the 3D world many years ago, as opposed to many contractors or the structural guys, which is what we're seeing, for instance, in the North American market. The contractor plays much more of that role. He'd have architects employed, but he's the interface with the client. And you know, architects get very excited when you start talking about the technology and talking to the concept that they can see their model grow in real time if they use the technology, the correct technology. On the structural side, I think it's quite obvious the benefit that they can have from having technology and the ability to model the as-built as it occurs. Here, Trimble acquired a company called Techless Structures, which is a very mature technology in steel or concrete design of buildings. And again, the idea to bring them into the families to have that continuity over the continuum. A very important part here is collaboration. You know, having all your different professions and trade work in a true 3D world, collaboration becomes an important part, whether that's virtual collaboration or on-site. But again, knowing what's going on out there allows you to adopt your design very quickly. The whole MEP phase, the mechanical, electrical, and plumbing trades, this is probably one of the phases in a typical vertical building construction that can benefit the most from technology like this, the concept of 3D modeling and mapping and modeling. It's a very discontinuous process at the moment. You find your mechanical engineers, your electrical engineers, and your plumbing guys, your HVAC guys, all still live, first of all, in a very 2.5D world. There's a lot of paper involved, there's a lot of 2D design going on. Plus, these designs are happening in isolation. And what happens is often there's prefabrication involved, but when they get to site and they try and put all of this together, there are loads of clashes. And there's redesign, and you can just imagine trying to get all of those trades onto site, discussing clashes, because they've now discovered that the air conditioning, which was prefabricated, runs into a structural beam, runs into a electrical service or plumbing service. And having all of those clashes sorted out before you even break ground is a massive advantage. And that's all dependent on being able to live in a 3D world, but as you construct as well, to make sure it ties to that design. The general contractors and construction managers, it's obvious the benefit they're going to get. They've always tried to model the building as it goes up, but I think what you're finding with the convergence and the advances in technologies like this, it just makes their life a lot easier. And then even the owners or developers of a vertical building construction, the fact that the design and the process is underpinned by a 3D model as it's being built has got benefits to them way beyond just those ones that I mentioned. In terms of managing facilities, having effectively a very accurate 3D GIS of your facilities out there has got massive benefits in terms of expansion or commercialization of those properties, understanding in 3D where the services are, what's the quality of the product, etc. So, you know, the point really here and the relevance to the talk here or to the conference, the topic of the conference is all of that I've described hangs off an accurate 3D model of that design, of that structure. Whether it was designed in that way or not, but the ability to have that stored in 3D is what all of those benefits we discussed hangs off. It's pivotal and it's almost overlaying on that whole process. So you're finding more and more from to start off with, or to refer to where I started off, more and more industries are becoming attractive for technology companies to address vertically because of technologies like this. But the approach is to expand that vertically. So that's just my overview there, and yeah, I think while Brent sets up here, I'm happy to take any questions. Okay, sure.
About the technology on the data capture side of things, where we are. We're going to look at two different technologies. There's the TX5 scanner we've got here, and there's this Z1, which I believe we spoke about yesterday, called also known as Zebedee. Quite exciting new technology. So to start off, I'll just go through the TX5. The reason I've decided to choose this scanner is for these 4 reasons. It's easy to use, it's efficient, very compact and lightweight, and it's very economical. These 4 factors make it more accessible to people that wouldn't typically have chosen to capture data in a 3D environment. They would have used other techniques such as double stations, tape measures, those type of things to create capture information in a more conventional 2D type environment. But as you'll see just now, it just makes it more accessible, more appealing to people to capture data in 3D. So, as I say, it's easy to use. It's got just a little touchscreen panel here on the front. It's all built in. There's no external connections you need to have with your laptops or anything. I'm just going to show you just the interface of it and just demonstrate how easy it is to use. It's got a built-in Wi-Fi, so I'll just connect to it. So you can connect to it remotely and start your scans remotely. What you're seeing here now on the screen is exactly what the user would see on that interface. You can set up your projects, set up different profiles. You can manage different profiles depending on the different environments that you're in to best capture the data in that type of environment. So I'll do a scan now. I'll just choose a standard profile as an indoor less than 10 meter range. You can see here typically how long this is going to take. If you look at about 3 minutes to do a full 360-degree scan and capture images. Quite simply hit the start scan button and in a few seconds it should start scanning. So while that's going on, I'll carry on. As I say, it's compact and lightweight, so when doing indoor scanning, usually you see the whole thing fits into a box this size. This is all you need to take to site nowadays. Fits on a little camera tripod, so usually indoor scanning, there's lots of setups. You always have to get around objects, so there's multiple scans, so it's lightweight. It only weighs 5 kilograms. It's quite easy to move around and take to move traverse around your building. That's done. This example is not really, it's not indoor mapping as such, but I just wanted to demonstrate how, because of its size and weight, how versatile it is. This is just an example of a silo that people need volumes of. They typically can be quite difficult things to get volumes of. They usually have small accesses, and clipping them, usually sometimes the material that's stored inside these things is very valuable, and people need to have accurate measurements of the product that's inside them. You can see in scanner, this is just a normal, that's just a survey pole, your standard pole that you would use for to have a prism on, to work with your total station. Just put the scanner on the end of that pole, hang it upside down on the side, you'll open it on top of that silo, and from that minute-and-a-half scan, the scan the silo, about 3 minutes to create your accurate volume of your product inside there. So, another example, just of it being versatile, this was you can see it, this is the tripod that it's busy standing on is just something that's meant for lighting on a film set. These guys here are busy using this scanner for creating models within the film industry, where they go and scan different environments, they scan their film sets, and they use those point clouds as a base to be able to create models for their 3D, for their computer graphics within the films. This here is, that's the point cloud that was created after the scan of this vehicle that we're going to use. So you can imagine something like this, being able to get it into environments such as your ceiling cavity, where all the mess happens just above here, where you want to capture all the data for your services and your air conditioning ducts. So it's quite a lightweight solution for that type of environment. So it's efficient. You can rapidly capture high resolution data, and it's got the built-in camera creates a 370 megapixel, 360-degree panoramic image, which is then you can apply the RGB values to your point cloud, so you can colorize point cloud out. So this is an example that people probably would not normally consider taking this. Previously, I've considered taking a scanner to do. It's just an office. Somebody needs to, they need floor plans of an office done. But with this, at 3 minutes a scan is 7 rooms in here. You're only going to spend half an hour on site collecting your data now. From that now you can, if the deliverable is still 2D, you can just create 2D from there. But you can also create a 3D models of the environment. Also things like if this was, you can see in this example, this was an extension that sort of went over the boundary line. Those kind of things are sometimes missed if the guys are measuring up building this phase and take measures. So you do get quite a good accurate model out of it. This scan is finished. What I'll do is I'll just go back here and have a look at. At the end of the scan, it just gives you a preview of what you can go in and you can view and you can see, just to make sure that you have collected the right information. You're happy with what you can see. And then basically you're ready to go again. You hit the start scan button and it'll go off and you view the tripod and it's ready to go. It stores the data on just on an SD card. The sizes of the scan, it's a 32 gigabyte SD card. I formatted it the other day, it had 170 scans in it, and it was about 20 gigabytes. So it's quite, you can put a lot of data on one card. So I just need to save the project for it to be able to import it. And now it's going to convert the file into its RealWorks format. It's going to apply the color values to the point cloud. It'll take a minute or so while that's happening. Carry on. Okay. So just on some of the technical aspects of this scanner, it's a phase scanner. It can capture up to almost 1 million points per second, 976,000 points per second. Its range is up to 120 meters. The accuracy 1.2 millimeters, standard deviation on this. As you saw, it's got built-in Wi-Fi, which makes it handy for if you do get the scanner into inaccessible environments. You can then start it remotely from any flash-enabled mobile device. You can use a cell phone to operate it. Got some nice integrated sensors, so it's got a thermometer built into it. So if you are like now just taking a scan of one room, the data that comes out of it is already the measurements you take from that. You're going to get true horizontal and true vertical measurements, as opposed to some scanners where your scan data is relative to the scan. So when you bring it in, you still need to do some form of initial registration and moving of your point cloud to get that. You just want to get some quick information on it. Okay. Let's have a look at that's just the data we've just collected. This is not the point cloud. This is your image. But there is at this stage there is still some sort of this intelligence behind this imagery. I can take measurements from this image. I want to take a true vertical image. I want to get a ceiling height. You can do it directly from there. And it's nice to be able to be able to show people this information in as a quick display. You're wanting to show something in the 3D. For example, some architects they need clearance heights. Engineers like to have floor levels. It's just nice to show there's environments where there's, like in this room, there's lots of different levels of boxing. It's very easy to display and send that information to a customer. You can then also just annotate things quickly. Yeah. And you can send that information off. You can create a PDF from that. And then also one of the problems, but one of the nice features of work using RealWorks to work with point clouds is that you don't always want to have point clouds creating massive data. You don't always want to have all that data to work with. So you can use this Scan Explorer to just extract the relevant portions that you're after. And you can, if you are modeling something, you just want to take small amounts of small area. So from now I can just do a polygon, and I can say I just want to extract a point cloud of that area to be able to model it. And then you bring that into RealWorks and just model that area. It makes the workflow of modeling a lot easier. Put this just to show you the point cloud, and I'll take out the entire point cloud, 5mm spacing, and just extract those points. Here at the bottom you can see the number of points going up. There we have the full point cloud. It will work. That's pretty much that sensor done. Now another technology, there's this Z1, simultaneous localization and mapping, SLAM technology. Now it's something that's been born out of the robotics industry, for robotics to be able to position themselves in and know where they are within environments, within unmapped environments. As you can see, there's a little scanner and an IMU sitting on top of a spring. You walk around, it's a line scanner, it bobs around, bobs up and down, scans as the motion goes, it moves, scan collecting data. Advantages, you can rapidly scan large areas, you can scan areas at walking speed. Portable, really simple to use, and there's the data processing is automated processing. So you download the data from your handheld device, you upload it to the web, it gets processed for you, and you download it again. Typically the processing time is the same as your data acquisition time. If you scan for 10 minutes, you'll be able to get a point cloud in that 10 minutes. As I say, rapid scanning. This here is an example of the building done in Spa 2012 in The Hague. Exactly a little video I can show you on that now. This model took approximately 8 minutes to capture and say 6 minutes to process. So just get an idea of how much data you can capture. Other examples of it recently, it was in September, there was a BBC documentary that they did on how they used the Zebedee to scan the inside of the Eiffel Tower, which hadn't been done before. It's narrow corridors, it's very difficult to do with a normal static scanner. And that was done in 20 minutes. Other difficult environments, things like
pizza.
Sorry?
Pizza.
Sorry.
Pizza.
Tower of pizza. Different scan, yeah. This is just other typically difficult environments would be staircases, stairwells. Yeah. A room on the 6th floor and the staircase going up to it. Another nice advantage of the Zebedee against other scanning methods is these are two very similar type environments. You can see the amount of shadow that you get from a static scanner, because you're moving around all the time, you're moving around all the objects, you get a much fuller 3D, fuller point cloud than you would from a static scanner. Some hardware specifications on that scanner. Data acquisition speed, 43,000 points per second. 3D accuracy, only 30 millimeters. Measurement range up to 30 meters. 270-degree field of view, so while you're walking, it's not scanning you the whole time. It's just blocks out a 90-degree field, so you're not scanning. And it weighs 665 kilos, and it's that size. So you may look at that there and say, well, that's a bit of a concern, that's only 30 millimeter accuracy. So you've got to weigh up the right tools for the right job. If you're looking for finer detail, you won't use the longevity. It's if you want to pick up cornicing, that type of detail, edging, you won't be able to pick that up in the point cloud. But because you pick up so much data on features like water, if you're trying to just create a 3D simple model, a box model, you can expect to get sort of 5 mm accuracy between your planes that you created. You're going to have a couple of million points along that wall. If you then take a best fit plane to that point cloud and you physical measurements between those planes, you're going to get about 5 mm accuracy on that. And that's it. Any questions?